So it seems to me that during this COVID crisis, we've seen a lot less attention paid to sustainability issues and greenhouse gas emissions and so on generally in the press. But of course, in the cement industry, it's far too important an issue for it to be put in the background for long. And LC3 is a very interesting product that has the potential to make a significant contribution to our medium-term achievement of the carbon reduction roadmap.
Scale. And this means that Portland cements will continue to dominate because they can be produced at a very low cost. We have the raw materials, which are very abundant and available nearly everywhere. They also have this very nice property that when you mix Portland cement with water, it has this period of a few hours in which you can move it onto site before it sets of CO2 we have. Of course, we have unlimited amounts of limestone, but once we go beyond levels of addition of about 15%, then this is kind of just a diluent, and we then have to use more cement to compensate, which of course doesn't help much. I'm not going to go into the details on these materials up here, but the important point is that they are not materials available in very large amounts. So worldwide, the only thing we really have which can increase this level of substitution are clays, which can be calcined, and these produce very good substitute materials. So to summarize that, I think it's important to emphasize there are no magic solutions out there that we haven't discovered. The best solution, and really the only one that's going to give scalable reduction of CO2, is to increase levels of substitute material. The only material that can really extend that level of substitution is calcined clay. And what we really discovered at EPFL was that if we now put together this calcined clay with limestone, we can get particularly high levels of substitution. And this is what, but with LC3, what we can do, we can substitute a further 15% of this clinker by limestone, and limestone has very low CO2 emissions. And even with this high level of substitution, as you see on the right here, after only 7 days, we get higher strength than the reference Portland cement.
The scenario where you produce LC3 in your plants, where you have access to your coal. Here, compared to the 30 USD of the OPC, producing LC3 will reduce your OPEX of 2 to 7 USD per ton.
I think if I do the calculation, the integrated plants, the $2 to $7, you know, if you took say 5, then that's probably a 10% improvement in EBITDA. You know, and maybe the grinding station is 10 to 20% depending on your pricing. You know, you could be in a market that's distant from limestone, but you know, again, it's a very substantial impact.
And it has the impact for, you know, all the grinding station in West Africa where the limestone is not present, which means that you have to import clinker, or sometimes you import normally cement. You could import clinker and mix with your local calcined clay, which has a huge impact for those countries, because you lower the cost, you lower the pressure on the foreign currency, which we always forget. You create job in your countries and you use local resources.
And location of all this mines of kaolinite, we have roughly 3.5 billion tons of kaolinite clay, you know, mostly actually located in the south and the east part. And here actually we see it from the observation of SEM, we see that actually after the thermal activation, you know, the calcined clay actually, you know, maintain, you know, the more or less, mostly actually the original morphology and structure of the road. The very high, resistant to the sulfate corrosion for LC350 cement concrete, as well as actually a very good, resistant to the chloride ingress of into the cement or concrete.
It's pretty much, it's pretty much the same. We have done studies of this with the Indian partners. This is published. If you go on the web page, you can find that publication, in which they produced concrete of standard grades of 30 MPa and 50 MPa, and the amount of cement they had to use was pretty much the same as Portland cement. It could even have been a bit lower in some examples.
With slag cement. Then practically, or in a practical application of the LC3 solution, there's also another solution. We try to actually to separate the calcium clay and limestone from the cement system to make the LC2 as a mineral additive. So we already conducted the LC2, the addition of LC2 with existing Portland cement, not pure Portland cement. We call it PO. That means a lot, say 20% of slags in the cement. It works very well. We can also add more LC2 in a Portland cement with certain amount of slag. It works very well. Because I just wish to follow the Karen's remarks about the durability of the concrete. We don't have the exact figure now, but think about the synergy coming from the use of calcium clay. The very the reactive actually alumina, as well as the silica contained in the metakaolin. Both of the components participate in the hydration in the reaction.